like that is the transportation problem. And now what we have to discuss is the assignment problem. An assignment problem, what we think is that assignment problem, this can be considered as a special case of transportation problem. And why it is called assignment, how it is said it is the special case of the uh, transportation problem, I will tell you. Assignment, simply the thing is that one job is assigned to somebody. That is what we are using the concept here. One job is assigned to somebody. And in this case, in this problem, what we have to think is that only one person will take one job, and only one job can be given to one person. A person cannot take more than one job. A job cannot be assigned to two person. That is the idea we are using here. That means one job is to be assigned to one person only, and one person has to take only one job. This concept we have to use. And just like what we had discussed, what we had seen in the case of transportation, these number are cost or charge, whatever it is suitable. Say suppose it is like this. These are the persons: A dash, B dash, C dash, D dash, E dash are the persons. A, B, C, D, E are the jobs. And here, say suppose if job A is given to A dash, the cost is 10. The cost is 10. Cost means it may be the salary or whatever it be. Mainly, we will consider the salary. And then if job A is given to, suppose job A is given to B dash, then it will be 5. Job A is given to C dash, it will be 10. And as I had already told you, only one job is given to one person. So suppose if job A is given to A dash, then B dash, C dash, D dash, E dash will not get the job. And suppose job A is given to C dash, then A dash, B dash, D dash, E dash will not get the job. That is the concept we have to use here. We have to use here. That is the concept. And that is why in this row, only one person will get the job A. And in this row also, second row also, only one person will get the job. And in this row also, only one person will get the job C. And likewise, for D also, only one person will get the job D. And for E also, only one person will get the job E. And that is why, see, in case of transportation, rectangular type we have seen, because number of items in one outlet or one factory, that may be different, and that is why it may be rectangular. But here, in this case, as number of jobs and number of persons are to be equal, it should be square here. It should be always square. It should be always square. And likewise, in the case of transportation, we call balanced transportation, unbalanced transportation. Likewise, here also we will have balanced and unbalanced assignment problem. But it should be balanced before starting the calculation. So suppose if it is not balanced, then how it is to balance, that will be explained in the algorithm also. And this is what we have to do. And then say, suppose job A is assigned to D dash, and then D dash will not take any other job. He will take only one job, that is A, and remaining others are to be assigned to other persons, other jobs to be assigned to other person. Our target is to obtain the minimum cost, minimum expenditure. So suppose if these are the costs, so suppose all these things, what we see is that if job C is given to B dash, it will have the minimum expenditure. From this, what we observe is that this can be selected as one. But while doing so, by selecting this, whether we will get our target or not, that we cannot see, because what we have to consider is only for not only for one person one job. It is for all the five job 5%, and that is why taking C by B Dias may not be suitable while considering for all the five job and 5%. And this is what we have to see for this particular problem. And for this 5 by 5 it may be easy, but say suppose the problem is like 10 by 10, 100 by 100, like that. See, in a factory how many persons may be there, how many people maybe the how many employee may be there, and how their jobs are to be assigned. These are all this type of problem we can do due to this assignment problem, by this assignment problem, in order to get the minimum expenditure. And if employees are more and more, then problem will be bigger and bigger, and jobs that is why likewise we may not be able to do easily, and that is why algorithm is necessary. And then that algorithm we will study here. One thing is that before starting this, some theorems will be necessary, that also we will discuss. And uh, another thing is that, see, say suppose this is the assignment problem. According to the theorem, we will know some theorems are there, we will know. Say suppose if all the entries in this row are subtracted by a fixed number. Say suppose 2 is subtracted from all these things, 2 like that, same number for all the elements, then that will not affect the result. That is one of the theorem, and that we will apply here also. Let us start from the problem. See, let us read together. I think most of you might study it, but let us read together. If there are number of jobs which are to be assigned to a number of people or machine, such that the assignment of a job to a particular person or machine would incur certain cost. Cost means what we had written within the box. Then the problem of determining a set or sets of alternative assignment which would lead to an optimal cost. Optimal in our case is minimum cost. Optimal cost is termed as the assignment problem. Note, assignment problem can be considered as a particular case of transportation problem, balanced and unbalanced assignment problem. And let there be m jobs and n number of people or machine. And suppose that assignment of the I job to the z person or z machine would incur a cost Cij. It is also assumed that a particular job can only be assigned to a particular person or machine. That I had already told you, a particular job, I'll repeat this again, a particular job can only be assigned to a particular person. One job per person. This according to this what we have to solve. And conversely, a particular person is capable of doing not more than one job at a time. We can thus would indicate the assignment of the I job to the J person. Then it is clear that, see, Xij. Xij is what? Xij value will be 1 if the I job is assigned to the J person or machine. 0 if the I job is not assigned to the I person or machine. See, what we have to do is that if the particular job is assigned to a person, then we'll think that that value is 1. If it is not assigned, then it is 0. Say suppose, let us come to this again. Say suppose this job is assigned to CDS 9. Then this will be 1 and others 0, 0, 0, 0. What we mean is that job A is not assigned to A Dias, that is why it is 0. Job A is not to assigned to B Dias, that is why it will be 0. Job A is assigned to C Dias, that is why it will be 1. And then that value will be 1 into 9. And likewise, 40 is also 0, 0. Then what we have? 10 into 0, 5 into 0, 9 into 1, 18 into 0, 11 into 0, like that. And then again, whatever be the value here after assignment, what we have is that it is 0, 0, 1, 0, 0. If this sum is to be find out, then it will be all 0 and only 1, 1, then that sum will be 1. always row wise sum, column wise sum, that will be always 1 1 1, that you have to know, that will be given there. And likewise in the column also, only one will be assigned, that value will be 1, others will be 0, and some will be 1. Then now let us come to that again. Then I already told you xij is 1 if it is assigned, xij is 0 if it is not assigned, I from 1 to m, j from 1 to n. Since for the fixed j, that is for a particular person or machine, only one job can be assigned, we must have summation I from 1 to m xij equal to 1. And what does this mean? Just I already told you all are 0 0 and only one is 1, and that is why row wise sum, that will be 0 0, 0 plus 0 plus 1 plus 0 plus 0. Likewise, that will be, it is always row wise sum is 1. Likewise, column wise sum also, it will be 1. And therefore, since the objective is to minimize the total cost, we get minimize z. Minimize z will be summation I from 1 to m, summation j from 1 to n, Cij, Xij. Cij is whatever it is written in the, it is given in the box, within the box, the cost for assigning one job, particular job to a particular person. And Xij's are either 1 or 0. Either 1 or 0. If it is assigned, it is 1. If it is not assigned, it is 0. And clearly, equation 1 to 4 is the mathematical formulation of the assignment problem. The assignment problem differs from the transportation problem because here AIs are 1 and BJs are 1. And the definition of XIJs are as given in 1. However, structurally, we can write assignment problem as likewise. This is how we can write the assignment problem. It is minimum z of this. This is the objective function, and subject to what? Summation xi are 1 and summation xij, I from 1 to m, it is 1. It is row summation, and it is column summation, summation j from 1 to n, xij 1. And xij always greater than equal to 0. I had already told you it is either 1 or 0 only. And again, if m not equal to n, it may be either m greater than equal to n or m less than n. In that case, the problem is called unbalanced assignment problem. And we have to make it balanced one. The corresponding problem is known as unbalanced assignment problem. And if, however, m equal to n, then problem is called balanced assignment problem. And let us see some statement of some theorem. Proof we will not discuss, only the statement we will consider. See, first theorem. The assignment problem remains unchanged with respect to the optimal solution if the elements of the cost matrix are increased or decreased by the same amount. That I had already told you, if first row is subtracted by a fixed amount, result will not change. Likewise, if it is added by a fixed amount, result will not change. And theorem 2, if ui, bj are arbitrary real numbers, and if c dash ij equal to cij minus ui minus bj, then the reduced cost matrix of a balanced assignment problem would give the same optimal solution as the original one. A particular element is replaced by some subtraction of two numbers, that also will not change. And according to this basis, we'll start our problem, we'll do our problem. See, subtraction of the row by same element, that we will do. Subtraction of the column by the same element, that we will do. And in that case, if both are subtracted from row as well as column, then two elements are subtracted, then it will come to this. And even though it is done so, the value will not change. That is why we will do that. Assignment problem, let us see the algorithm. Step 1. check whether the given problem is a balanced or unbalanced one. If it is balanced, go to step 3. If it is unbalanced, go to step 2. Step 2 will tell you how you have to make it balanced one. If the number of rows or columns is greater than the number of columns or rows, then add dummy columns. See, in case of transportation also, I had already told you, and dummies are to be added. And in this case, how dummies are to be added, what will be the form of the dummy, that will explain here also, so that the given matrix becomes a complete square matrix. As it is unbalanced transportation problem, it is not square matrix. Now we have to make it a square matrix, and with proper amount of capacity of the fictitious source and proper amount of the requirements of the fictitious destinations, the problem becomes a balanced one. And in the dummy row or column, the coarse elements are all 0. Go to step 3. See, I'll come to this problem and will explain you. Say, suppose this row is not there. This row is not there. It is you assume that it is only A, B, C, D, and it is A dash, B dash, C dash, D dash, E dash. In column it is 5. In row it is 4. It is not a balanced one. Then you have to add E with this as 0, 0, 0, 0, 0. Then 5 will be there. As cos are all 0, the problem, it will not affect to it will have no result to the problem, but the problem is a balanced one. And in that way, you have to make it a balanced one. Are you clear with this balancing? Okay. Then let us come to step 4. Step 3, step 3, okay. Determine the minimum cost in each row of the cost matrix. And if it is not 0, then subtract this minimum cost from all the elements of the respective row. Go to step 4. If it is 0, then subtraction is, we have to subtract 0. It is meaningless, no effect. And that is why if it is not 0, subtract the element. If it is 0, nothing to do. Step 4, do a step similar to step 3 for each column of the modified cost matrix. Starting reduce cost matrix is now ready, and go to step 4. Cover all the zeros in the RCM with least positive number of possible number of horizontal and vertical lines. If the number of such lines equal to the dimension of the problem matrix, then the RCM obtained can be taken as SRCM, and go to step 8. If not, go to step 6. See, in our case, dimension of the problem is 5 row, 5 column. Okay, step 6. Find the smallest cost of the RCM already not covered by the lines as obtained in step 5. Then 1. Reduce all the elements which are not covered by the smallest cost element. And next, increase all the elements which are not covered twice, that is at the junction of the two covering lines, by the smallest cost element. The new RCM is obtained. Go to step 8. These 2 points you may not able to understand here, and I'll show with the problem, that will be better. And let us step 7, repeat step 5. Step 8, check the rows successively until a row with a single 0 is found, and enclose this 0 inside a circle. This will be called later as assign 0. Since an assignment will be made there, put a cross in the cells of all other zeros lying in the column of the assigned 0. Repeat the process until all the zeros are examined. If tie occurs, break the tie arbitrarily. Go to step 9. And step 9 is check the columns successively until a column with single 0 is found. Encircle the single 0 and cross off all the other 0 lying in the row of the assigned 0. If tie occurs, break the tie arbitrarily. Continue in this way until all the columns are taken care of. Go to step 10. Step 10. Repeat steps 8 to 9 successively. If no unmarked 0 are left, the algorithm stops as the optimal assignment is obtained. If there lie more than one unmarked zero in one column or row, encircle one of the unmarked zero arbitrarily and cross up in this is the case for breaking the tie, and cross off the cells containing remaining zero in each row and column. Repeat the process until no unmarked zero are left in the SRCM. After obtaining the optimal assignment, the total actual cost can be calculated by adding the values of this in the assigned cell from the original cost matrix. And this is the procedure, and let us see in the problem. That will be some of the steps you might not be able to understand easily, but in the problem everything will be known. See, let us come to step one. The problem, let us see first whether it is balanced or not. Tell me whether it is balanced or not.
Balanced, sir.
Balanced, because 5 row 5 column, it is balanced. And now next step one, let us see the problem is balance one, and then see in the for this what you have to do is that you select this row, and what is the minimum element? What is the minimum element?
5.
5. Then what we have to do according to the algorithm? If it is 0, nothing is to do. If it is 5, what we have to do? 5 is to be subtracted
Subtract.
from all the elements. 5 is to be subtracted from all the elements. This will be 0. Others also will get after subtraction of the 5. And similarly for second row, what is the smallest element?
6.
6. And what we have to do?
Subtract.
Subtract 6 from all the 5 elements. Okay. Next is
2.
2. And what
2.
we have to do? Subtract 2.
Minus.
Okay. Next is
9.
9. Subtract 9. And next is 6. Subtract 6. This is for the row. And after that, we have to do for the column. Let us see what is that. See. First row is after subtraction. What is that smallest element? 5. 5 subtraction, it becomes 0, it becomes 5. Likewise, others also. Second row is like this. Third row is like this. Fourth is like this. Fifth is like this. And now then do the process for column. First column, what is the smallest element now?
1.
1.
1. Then what do you have to do?
Subtract.
Subtract 1 from all the
Subtract
5
1 from
elements.
every.
Hello, Oza. Oza. Where's that? MIT चे कईगी ओइना नो जा ꯑꯗꯨꯒꯤ ꯏꯟꯆꯥꯔꯖ ꯑꯣꯏꯕ ꯃꯤ ꯑꯃ ꯂꯩꯇ꯭ꯔꯣ ꯑꯣꯖꯥ? ꯅꯠꯇꯦꯗ ꯑꯣꯖꯥ, ꯏꯟꯆꯥꯔꯖ ꯑꯣꯏꯔꯤꯕ ꯃꯤꯗꯣ ꯑꯗꯨ ꯈꯪꯉꯒꯗꯤ ꯑꯗꯨꯅꯤ ꯍꯥꯏꯕꯗꯣ ꯑꯩꯅ ꯍꯥꯏꯐꯦꯠ ꯃꯃꯤꯡꯗꯨ ꯀꯩꯅꯣ ꯇꯧꯈꯤꯕ ꯌꯥꯏꯗꯅ. ꯑꯗ ꯑꯗꯨꯃ I amtang hang ke do za hoden pung kano da I kano tar ko phone amtang tor agyo za I am hang hello. Okay, then from first column 1 is to be subtracted, and what about the second column?
2, sir.
Smallest is what? Smallest element is
0.
0, no subtraction, because smallest is 0. And third column, smallest is
2. 0,
0,
0,
is
0.
0.
Yes, sir. 0.
0, no subtraction. And fourth column, smallest is 2, we have to subtract 2. For third column, smallest is 3, we have to
3.
subtract 3. Okay, then result is this. Result is this. And then what is this? Respectively applying step 4, we get this. Up to step 4, we are done. And then next is what? Next is, see, zeros are here to cover the 0. To cover the 0, we have to draw lines. We have to draw lines. Arbitrarily, you can draw, but there is some technique also. Technique I will not study today. We'll do later on. But today, let us do by arbitrary drawing. See, here in this column, 4 zeros are there. Then we draw one line here. 4 0 already covered. And first, we can draw for second column, third column, like that also. If you draw in that way, then you will get 5 lines. Say all you can, if you draw 5 vertical lines, it will cover all the 0. That is one thing. Similarly, if you draw 5 horizontal lines, you will get all the zeros will be covered. That we didn't like. What we have to do is that we have to draw minimum line. Minimum, if possible, less than 5. 5 is the maximum. 5 is the maximum, and minimum line to cover all the 0. Say, suppose you see, by covering this 0, you can draw one horizontal line. This another horizontal line. This another horizontal line. With this another horizontal line. With this another horizontal line. 5 lines we had drawn, and then all the zeros are covered. That we didn't like. And what we want to get is that minimum line to cover all the 0. And here we get only 3. 1, 2, 3. Whether these 3 lines cover all the 0 or not. See, check it and tell me whether these 3 lines cover all the 0. Whether these 3 lines cover all the 0. Is there any 0 left not covered by the lines? It is covered.
Yes, sir.
Covered,
It is
sir.
covered. It is covered. But how many lines you get? 3.
3.
Line is 3. And what is the dimension of the problem?
5 cross 5.
5. 3 is less than 5. 3 is less than 5. Number of line is 3 and dimension is 5. Less than the dimension, and that is why it is not saturated. We need to solve further. Just like what we have done in case of simplex. If all the values are negative, then all the values are positive or 0, then we will stop saturated. If some negatives are there, then we have to do the next iteration. Likewise, we will start for the next iteration again. Before starting that iteration, see, one more step is necessary. You see the elements like 4, not 6. 4, 4, 11, 3. How I am selecting? Numbers not covered by the lines. You search the numbers not covered by the line. It is 4, 4, 11, 3, and 8, 3, 6, 3, 4, 8, 11, 1. Among these, you select the minimum, smallest. What is the smallest? Which one is the smallest?
1.
1. That is why I circle it. It is 1. That is why I circle it. I circle it. This one we have to subtract from all the elements. See, from 4 also we have to subtract 1, 4 also 1, 11 also 1, 3 also 1, not from this 0, and then not from this 6. Those not covered by the line we have to subtract 1. From 8 also, from 3 also, from 6 also, from 3 also, from 4 also, from 8 also, from 11 also, from this 1 also, 1 will be 0 after subtraction of 1. Are you clear this point? Point is this: you select the smallest element among those not covered by the lines, not covered by the lines, and subtract that element from all the elements not covered by the line. And then here, see, this 13 and 0. 13 is at the join, crossing, and this 0 also at the crossing. On these two, increase 1. Add 1 at this smallest 1. That is, this will be 13 plus 1, 14. This will be 0 plus 1, 1. Are you clear this point? From the numbers not covered by the line, select the smallest and subtract that number from all the elements not covered by the line. But for those elements at the intersection of the lines, increase by that amount. Increase by that amount means in our case it is 1. See, let us see the next table after this. See, what is this? This becomes 0. Earlier it was 1. And earlier it was 4. It becomes 3. And earlier it was 13. It becomes 14 because it is the junction. And earlier it was 0. It becomes 1 because this was also junction. And now, in this again, see, you have to apply, see, the dotted lines are inserted following step 5. Since number of covering line is 3 and less than 5, dimension of the smallest elements 5 occurs cell in circle. Applying step 6, we get this below. By the above, we process a new 0 is introduced at 5 cell, but 1 0 is lost at this cell. However, in that process, the number of covering line is increased by 1, and since the total number is still less than 5, see, again here, we have to draw again. In this case, we have to draw again lines, horizontal or vertical, to cover all the 0. And how many lines we have? 1, 1, 1, and this one. Here also, number of line is 4, that is less than 5, dimension of the problem. And then again, still another iteration is necessary. Then we have to search the smallest element from the elements not covered by the lines, and it is 3. 3 is subtracted from the elements not covered by the line, and here junction, this one of the junction, this one of the junction, this one of the junction, and here at this intersection of the lines, you have to increase by 3. This also increase by 3. This also increase by 3. And now we will have this table again, and here we draw again number of lines to cover all the 0. And in this case, what we have, a number of line is 1, 2, 3, 4, 5. We cannot draw less than this, and this is equal to the number of equal to the dimension of the problem. And now saturated, and problem stops, and the assignment starts. See, we are considering only the zeros here. See, from here we are reproducing this table: 0, 0, that is 0, 0. This 0, 0 comes here. This 0, it is here, and this 0, it is here. This 1, 2, 3, it is this. And now in this table we have to make the assignment, and where the job is to be assigned, that we will know here. And how that is to be done, that we will do in this way. See, and now let us start the assignment here. You see the first row. First row, how many zeros in the first row?
2.
Tell me, how many zeros in the first row?
2.
2. Then leave it. Go for the next row. Second row, how many 0?
1.
1. Now you can start assignment here. See, it is assigned. It is assigned, and you have to make a circle here. And if there is any zero in this column, you have to make the cross. You have to make the cross here. And it is assigned. Then what does this mean? Job B is assigned to the person CDS. Is not it? B is assigned to CDS. That is done. And then next, go to the next row. How many zero?
2,
2. Leave it. Go to the next row. How many zero?
1,
1. Then assign here. Assign here. Assign here. And then what are the zeros in this column? This 0 you have to cross.
3.
This 0 you have to cross. In this column. In this case, as zeros are not there, we are not doing. But in this case, 2 more zeros are there, then we have cross. And then go to the next row. How many zeros still left? This is cross. How many zero? 2. 2 0 left. This is cross, only 2 0 left. And 2 0 we cannot assign. Then come to the first row again. Now it becomes only 1 0. This 0 is left. This already crossed. And you make the assignment here. Then job A is assigned to Adias. A is assigned to Adias. Then in this column, you cross this 2 0. This 2 0 you have to cross. And then now what about the second row already assigned? Third row assignment is done here. It is assigned. And then no 0, no crossing. And then 4, this already assigned. 4, this again now, this is already crossed. This is also already crossed. Only this 0 is left where here assignment is made. Then now we will see this. See, for the first row, first row 2 0, no assignment. Second row 1 0 assignment. And next is what? Third row 2 0, no assignment. Fourth row only 1 0, assignment is made. Circle means assignment made. Other 0, cross, no assignment. Okay. Then again, first row as it is only 1 0, assignment made. And then this 2 0, it is cross. This is also already crossed. This is also already crossed. And then this will have assignment. This will have assignment. It is coming here. See, this is the assignment. This is the assignment. And then according to this, what we have, first job is assigned to A is assigned to Adias, and B is assigned to CDS, and C is assigned to DDS, and D is assigned to BDS, and E is assigned to EDS. And then it is written like this. In other words, the assignment would be like this: A to ADS, B to CDS, C to DDS, D to BDS, E to EDS. And the total minimum value is 10 into 1, that is 10. Simply we can write 10 plus 6 plus 4 plus 9 plus 10 equal to 39. 39 is the least assignment. And how this 39 comes is that if you see to the original table, it will be like this. See. Okay, this will have value 10, and that is why it becomes 10 here. This will have value 6, and that is why it becomes 6. This will have value 4, cos 4, that is why 4. This will have 9, that is why it is 9. And this will have 10, that is why 10. Adding, it is 39. 39 is the result. And this is how we have to solve the problem. Is there any doubt, any confusion? Then you can ask me. Anybody, any student? Can you do this?
Yes.
Okay, see, even though you can do, see, while drawing the horizontal and vertical lines to cover the zero, we are doing arbitrarily, and there are some procedure is there. Regarding that procedure, next class let us discuss, and that will be more easier. See, drawing arbitrarily, what will be the mistake is that, say, suppose it comes 5 line, even though it is not 5, it becomes 5. 5 is very obvious, it will always become 5. And then in that case, what you will think is that you already got the situation, and you will stop the iteration, and you will try to get the answer, and in that case it may not happen. And that is why, for that, better to follow the procedure, and that let us discuss next time. I'll send you the notes parts, and after that let us discuss. For today, let us stop here. Okay.